In this video, we will learn about scattering of light. So, scattering of light is a process due to which light gets deflected and diffused all over as a result of its interplay with the tiny matter particles. See, when the sunlight enters the Earth's atmosphere, it interplays with atoms and molecules of the atmospheric gases and gets scattered by the gas molecule. Scattering also takes place when light passes through a colloidal solution, mist, or smoke-filled room. Now, the color of a scattered light depends on the size of scattering particles. Lord Rayleigh gave a scattering law according to which the intensity of scattered light from fine scattering particle is inversely proportional to the fourth power of wavelength. So, the scattering intensity is inversely proportional to the fourth power of wavelength. Okay? Now, as per Rayleigh's law, the violet light is scattered the most and red light is scattered the least. However, large size scatterer particles scatter light of all colors uniformly. Now, there are some examples and application of the scattering of light. First of all, the blue color of the clear sky. So, the air molecules and fine particles that are present in our atmosphere have a size smaller than that wavelength of visible light. Therefore, they prominently scatter blue-violet light of shorter wavelength, but red-orange colored light of longer wavelength is scattered the least. Now, the scattered blue light enters our eyes and we can see the clear sky as to be blue. Now, of course, the violet light is scattered even more prominently than blue, but our eyes are less sensitive to violet light. Hence, the sky appears blue to us. Second is the black color of the sky in the absence of atmosphere. If one looks at the sky from a spaceship, the sky appears to be dark or black as there is no scattering of light due to no atmosphere in the space. Again, the sky appears dark when seen from the surface of the moon. Third is blue color of ocean water. So, water in lakes and ocean, when we see from a distance, appears to be blue in color on account of larger scattering of blue light by water molecules. Reddening of the sun at the sunset and sunrise. Ordinarily, the sun appears to be yellowish white, but at the time of sunrise and sunset, it appears to be reddish. At the time of sunrise and sunset, the sun is near the horizon, right here, and light rays from the sun passes through a larger distance in the atmosphere. So, light of shorter wavelength is mostly scattered during this passage, and only the least scattered red light of longer wavelength reaches the observer's eye. As a result, the rising sun or the setting sun appears to be reddish. However, at noon, as the sun is overhead, light from the sun travels relatively shorter distance. As a result, only a little of a blue and violet colors are scattered and the sun appears yellowish white. Fifth is white color of large clouds. So, large size cloud appear white while floating in the sky because large size particles scatter light all the color uniformly. The sixth point is that the danger signals are of red color. So the danger signals are invariably of red color because red has the maximum wavelength, so it will scatter the least in fog or smoke. Therefore, the red color signals can be easily seen even from a larger distance. Due to the same reason, red color danger signals are fitted on the top of skyscrapers to ensure that aircraft pilots can see them clearly from a large distance while flying over there. I hope this topic is clear to you. Thank you.